Okay, motion in a straight line topic is over. So now we are moving to the next physics topics. Now we have fourth unit, fifth unit, ninth unit. Fourth unit is Newton's laws of motion. Fifth unit is friction. Ninth unit is resultant force. These topics are related to force. So we cannot do questions related to one of the topic because we will get the questions with the combination of these topics. Most of the questions will be combination of all these topics. 4th unit, 5th unit and 9th unit. So what are we going to do? We are going to do questions from 2014 to last 10 years questions by combining all these 3 units. Now combination of these units only we are having part 2 questions. Part 2 questions you won't get only related to this topic or only related to this topic. In part 2 questions, all these topics will be combined together. So we will be discussing by combination of all these questions, discussing the part 1 and part 2 questions. First we will finish off all the part 1. The MCQ parts will finish off. After that we will come to the part 2 questions. Now the voice notes will be given in the WhatsApp group. I will be giving short notes for 4th unit, 5th unit and 9th unit, and there will be a small voice note for each. And yeah, and then you can check this recording on the YouTube. Now we'll start the questions. I will be sending the questions in the group. Yeah. All are prepared, but some units have to be prepared. Yeah. Friction, sorry, Newton's laws of motion, friction, resultant force, turning effect of force, equilibrium of force, hydrostatic pressure, work energy power, current electricity, waves and application, optics, heat, power and energy of electrical appliance, electronics. These are MCQs. Last 10 years MCQs specified into different topics. Likewise, I will be giving for part 2 also. Part 2 will be combination of both structured essays and essays. And yeah, I will be sending this into the group, but there are some things to be added into it. After it's added, I will send to the group. Now, 2014. 2014. Take 36th question. This is a very good question. This will help you to understand the complete theory, and not the complete theory, but the most of the part of theory will be theory is included in this question. Also, most of them might get it wrong. Please check it. 2014, 36th question. A box of mass 2 kg is kept on a table as shown in the figure. The box is moved along the table by applying an unbalanced force of x Newton parallel to the surface of the table. The frictional force acting on the box by the surface of the table is y Newton. Consider the following statements. What's the area they have given? This area they have given. That is this area. Is a rectangle? No? Sorry, a rectangle. Yeah, this area is this area. This area. Yeah, remember what this is. Let me shade only one portion. Yeah, this is 450 centimeters square. This is 900 centimeters square. So check the key terms they have used. Now let me, yeah. Box of mass is 2 kilogram. Next point, for a table as shown in the figure, along the table by applying an unbalanced force. Unbalanced force. This is the key term. Unbalanced force is x Newton. Let me put as x. X parallel to the surface of the table. Parallel the surface of the table. Frictional force acting. Friction. So here it is being kept on a surface. That surface is not smooth. It has a frictional surface. These are the key terms. But the most important point is, important term is unbalanced force. What do you mean by this unbalanced force? Now, let me take a box. Let me take a box here. And let's take this is kept on a surface which has a friction. Let's take that it has a friction of 5 Newton. And then to move this object, I'm giving a force of 10 Newton. So what's the resultant force? I mean the unbalanced force, resultant force or unbalanced force. Unbalanced force. What is the unbalanced force acting? 10 Newton minus 5 Newton, that is equal to 5 Newton. So the unbalanced force acting on this is 5 Newton, right? This is what is known as unbalanced force. The resultant force acting on it in order to move it. And 10 Newton were applying. But now let's take like this. There is no friction. Now this friction, the surface is smooth. Surface is smooth. I'm applying a force of 10 Newton. Now what is the unbalanced force? Now the unbalanced force is 10 Newton. Unbalanced force and the given force is equal because there is no any force acting in the opposite direction. Okay. Now let us take, now this is smooth surface. If it has a friction, as I said earlier, there will be a friction of 5 Newton. So unbalanced force is 10 minus 5, that is 5 Newton in the forward direction. We should mention the direction because force is a vector quantity, not a scalar quantity. If it is a vector quantity should have a magnitude and a direction. Therefore, 5 Newton in the forward direction. Suppose, let's take, I tied a string for it. 10 Newton, here 20 Newton. Not friction, I have kept in a surface. Now this is a smooth surface. Smooth surface. So this smooth surface, I'm giving a force. I have tied two strings. I'm pulling this with 10 Newton, pulling 20 Newton in the backward direction. So what is the resultant force acting on this object? That is, now here 20 Newton is greater than 10 Newton. Therefore, it is obvious that this object will move in the direction. That is practical. Yes. Therefore, the resultant force or the unbalanced force, unbalanced force, unbalanced force is 20 minus 10, 10 Newton in the backward direction. This is what is known as unbalanced force. So, likewise, in this question, so you know what is this unbalanced? In this question, they have said unbalanced force is acting. They haven't said the direction. It can be in the right, forward direction, the to right, or it can be to the left, any direction. I will take that an unbalanced force is acting on the forward direction. That is x Newton. X Newton is acting in the forward direction. And also, it is said in the question, this is a frictional surface. If there is friction, in what direction will this force, the frictional force will be acting? The frictional force will always be acting opposite to the direction of the motion. If this object is moving to the right side, frictional force will be to the left side. If this object is moving to left side, frictional force will be to the right side. So, yeah, I will take this as a surface. There is a frictional force that they have given in value. So, yeah. No. Yeah, frictional force is y Newton. Frictional force is y Newton. So, the y Newton force is acting in the forward direction. Initially, the object is at rest. When the object is at rest, there will be a force in the, there will be a force, frictional force. That is static frictional force. When the object is at rest, frictional force is acting. That frictional force is static frictional force. So, I'm going to apply a force, let's take F. I'm going to apply a force F in the forward direction. I'll let this as a forward. In the forward direction. Okay. When I apply a force in the forward direction, when that force is greater than y, there will be a frictional force. I'm going to apply a force. I'm going to apply a force such that it is greater than y. This force is greater than y. If this force is greater than y, it is for sure that this object will be moving in the forward direction. So, in this instance, what is the unbalanced force acting? Unbalanced force acting is equal to F minus y, right? F minus y. The external force. F minus y, unbalanced force. It is said in the question, unbalanced force is x Newton. So, unbalanced force is x. X is equal to F minus y. F minus y. F minus y. Okay, now we'll read the statements. Magnitude of the external force applied in the direction of motion is equal to sum of x and y. Now this is the external force I have applied now. I have taken this as F. Okay, this F is equal to, if I take this minus y to the opposite side, to this side, it will become plus x plus y. So, statement A is correct. I hope you understand it. You should have understood it. Therefore, statement A is correct. Magnitude of the acceleration of the box is half of x. Let's take this statement. So now the unbalanced force acting is x Newton now. You know that force is equal to mass into acceleration. Who said this? What is the law? Newton's second law. Acceleration is directly proportional to f. Okay. According to Newton's second law, you know f is equal to m into a, right? So what is the force acting? Force acting is x Newton. X Newton no. X is equal to, what's the mass? Mass is 2 kilogram. 2 kilogram into acceleration. Acceleration is x by 2. Statement is B is also correct. The magnitude of acceleration of the box is half of x. Half of x. X by 2 means it is equal to half into x. Half into x. Half into x. Half of x. Into means of, no? In mathematics, into means of half of x. Therefore, B is also correct. See the C part. When the surface area of 450 centimeters squared is kept in contact with the table and applied the same unbalanced force x in the same direction, the frictional force will be half of y. That should be wrong. Why it should be wrong? If you need note down any important points, you can take a screenshot and you can write it. Statement C. Frictional force. Now, frictional force depends on two factors. Friction depends on two things. One is the nature of the surface, and the normal reaction. Normal reaction. Nature of the surface. What is this nature of the surface? This surface can be a smooth surface or it can be a rough surface. If smoothness of the surface increases, then the friction will reduce. If roughness of the surface increases, friction will reduce. So, friction has an effect on the nature of the surface. It can be a smooth surface or rough surface. Normal reaction. Now I have a force, sorry, I have an object. There will be a force in the downward direction, that is mg. From the surface, there will be an upward direction r, according to Newton's third law. Every action has an equal and opposite reaction. So this object is pushing the surface down, the surface is pushing the object up. This will create a normal reaction. Therefore, frictional force depends on normal reaction. And how it is frictional force depend on normal reaction, you know. But this frictional force is directly proportional to normal reaction. If I increase normal reaction by 2 times, friction will increase by 3 times. Sorry, 2 times. 2 times. If I increase R by 5 times, friction will increase by 5 times. If I increase R by 10 times, friction will increase by 10 times. And you know the equation, friction. For friction, I have put Fr. Okay. Friction is equal to mu into R. You know, when something is proportional, to equate it, you should add a constant. That constant is this mu. What is this mu? The coefficient of friction. Coefficient of friction. Coefficient of friction. Okay. So friction depends on these two things. And also, in theory, you must have studied, now the in detail, in the textbook it is given in detail. There is an experiment also. You should keep like this. After that, you should keep in this direction. Likewise, they have explained to you. So, what is it? Friction doesn't depend on area. Friction doesn't depend on area. Therefore, in this object, it can be 450 centimeter square in contact with the surface or 900 centimeter square in contact with the surface. In both the instance, the friction will be same. Friction will be y, not half of y. Therefore, this is wrong. Answer should be first. Only A and B are correct. Is a very good explanation is given. Please note down all the important points. You write down the explanation. Okay. Therefore, I'll clean it. Two 2014, that's the wrong question. We move to 2015, 32nd question. Shown in the figure, an object of mass 1 kilogram moving at a uniform velocity. 2015, 32nd. As shown in the figure, an object of mass 1 kilogram moving at a uniform velocity of 4 meters per second subsequently came to rest due to uniform deceleration. If the time that is decelerated is 2 seconds, select the answer which gives its deceleration and the momentum before the deceleration starts, respectively. What is meant by this respectively? Now in the question, which gives its deceleration and the momentum before the deceleration starts. Respectively means first they have given deceleration. Secondly only they have given momentum. Therefore, in the answer, first should be the deceleration. Secondly, it should be momentum. Okay. Therefore, yeah. In physics, always put a diagram. It will be easy. Here we have an object. Initially, it is moving with a uniform velocity of 4 meters per second minus 1. It has a mass of 1 kilogram. After that, there is an force acting in the opposite direction. Because of that force, there will be an acceleration in the backward direction. That acceleration is in the backward direction. Therefore, this object will be decelerated and it will come to rest. Means D is equal to 0. This is what is happening here. Which gives its deceleration and the momentum before deceleration starts. First, we'll find the deceleration. What's the equation you can put? They have given time in seconds. 2 seconds. You don't know the distance. If you don't know distance, what's the equation you can put? V squared is equal to U squared plus 2AS. You can't put this equation because you need to find the acceleration. To find the acceleration, you don't know S, therefore you can't put. They have given time, so you don't need to think of this equation. V is equal to U plus 8. That should be the equation you should use here. You know final velocity, that is 0. You know initial velocity. You know the time they have given, it's 2 seconds. You can find the acceleration. And why you can use S is equal to ut plus half at squared. S you don't know. Acceleration also you don't know. If there are 2 unknown terms in an equation, then you cannot find one. You cannot find acceleration here. S is not given. Acceleration you don't know. You should find the acceleration. If you need to find the acceleration, then S should be given. Because S is not given, you can use this equation. Therefore, V is equal to U plus AP. Final velocity 0, initial velocity 4, and plus A we should find, that's 2. Therefore, I'm going to take this plus 4 to the opposite side. Therefore, minus 4 is equal to 2A. A is equal to minus 2 meter per second minus 2. Answer is given in the minus. Therefore, it should be deceleration. Acceleration minus 2 meters per second. What is this momentum? Momentum is the reluctance of an object to stop its motion. That is what is known as this momentum. Momentum E is equal to mv. Momentum, let me put this symbol P. P is equal to m into v. What is this m? Here, I'll give you the full form. Momentum is equal to mass into velocity. Mass into velocity. P is equal to mv. They have asked the momentum. Initially, it is moving with the uniform velocity. Mass is given. Mass velocity is given 1 kilogram into velocity is 4 meter per second minus 1. That is 4 kilogram meter per second minus 1. Now, what should be the answer? Answer is first one, right? Acceleration is minus 2. Deceleration is 2, just 2. 2 meter per second and 4 kilogram meter per second minus 1. Answer should be first. Yeah, answer 1. Two 2015. Finished. Now we'll go for 2016. That is the kind of question. That is the second question we have done it right. That is first question. Limiting frictional force between two objects with rough surface in contact depends on. I said you earlier. What is limiting friction? Now this is the graph, right? This is static friction. Now all these static friction will be acting. Static friction. Friction. With force. From here to here, the object will be at rest. Static friction will be acting. At this point, when the object just starts its motion, when the object just starts to move, friction acting is limiting friction. And then it's dynamic friction. When the object starts when the object is in motion, when the object is moving, dynamic friction will be acting. This is static friction, limiting friction. From here to here, all are static friction, limiting friction, and then it's dynamic friction. Dynamic friction. FD. F dynamic. Dynamic friction. It can be static, limiting, or dynamic. The friction is same. Friction depends on the nature of the surface. It can be smooth or rough. And then the second one is normal reaction. The area of the now see the statements. 31st question, first statement, area of the contact surface, no, it's wrong. The normal reaction and the nature of the contact surface, yeah, it's correct. Normal reaction and the nature of the contact surface, it's correct. Nature of the contact surface and area of the contact surface, it's wrong. Area of the contact surface and the normal reaction, it's no wrong. Not area, two factors, nature of the contact surface and the normal reaction. Therefore, 31st one, answer 2. First 32nd done. Yeah, 37th one. 37th one, under resultant force. 2016, 37th one is under resultant force. Resultant force is of two types, collinear and parallel. Collinear and parallel. What is collinear? The forces will be acting on the same line of action. If I take this object, I'm giving a force here, I'm giving another force here. This force will be acting on the same line. This is what is known as collinear. What is this parallel? If I give a force like this, and then a force like this, these two forces are parallel. So it can be like this. These two forces are parallel. It can be in same direction, opposite direction.